So in this question, we've been told that a particle is projected vertically upwards with an unknown speed. So the speed at the moment is u meters per second. From level horizontal ground, the particle is moving freely under gravity and returns to its starting position 5 seconds later. So that's quite a lot of information we've been given there. The very first thing I want to do is I want a diagram of what's going on in this situation. So level ground, so I'm just going to show the ground here. The particle is going to start from the ground, it's going to go up into the air. At some point it will change direction and it will head back down to the ground. I'm also going to indicate the positive direction. The initial direction of movement of this particle is up, so I'm choosing that as the positive direction. That's going to help me to get the correct value for acceleration, the correct value for A later on. Okay, let's collect the SUVAT variables that we're aware of. The displacement is going to be 0 because we're talking about when it returns to its starting position. So displacement is 0. Initial velocity is unknown and it's what we're actually looking for here. Final velocity is also unknown. Acceleration is going to be negative 9.8. Gravity is working against the initial movement of this object. Gravity is not helping it to move in its initial direction. Apart from that, my positive direction is up, while gravity acts downwards, so it needs to be a negative value. Okay, and the time that we're looking for, we've been told that it takes 5 seconds to get this displacement of 0. Okay, so that's enough to substitute into a formula. We're going to use S equals ut plus half at squared, and we just substitute in what we know. The 0, u is what we're looking for, we'll make that the subject. Time is 5, and the acceleration negative 9.8. Okay, so just some rearranging from here. U is going to equal 4.9 times 5 squared, all divided by 5. I don't even need to multiply the 5 squared to get 25. I can just cancel these out. 4.9 times 5, I can do that in my head, 24.5. So the initial velocity, 24.5 meters per second. Next, we're asked to calculate the greatest height the particle reaches above the ground. So this is going to be at the peak of its flight path, the highest point it gets to. And we know that at that highest point, the velocity or the current final velocity is going to be 0. So let's set up our SUVAT variables again. They're going to change this time round. It won't be the same time that we're working with, and it won't be a displacement of 0. So unknown displacement, initial velocity 24.5, final current velocity of 0, acceleration still negative 9.8, and it's an unknown time. I say it's an unknown time, but actually symmetry could have let us know that that will be 2.5 seconds. It's going to be half of the flight path of this particle. So actually I could have used 2.5, but let's stick to the things that we know or have deduced so far. Okay, so once again, putting these into the correct formula, it looks like this is going to be v squared equals u squared plus 2as. We'll substitute in the 0, the 24.5 squared, acceleration, and we're looking for s. Okay, so rearranging, I can just type this into my calculator all in one go. 24.5 squared divided by 19.6 gives us 30.6 meters. The displacement, 30.6 meters. So that's going to be the highest above the ground that this particle travels.